Hey IB Math Kids, this is Mr. Claver coming at you from my house. I'm going to try to walk through section 7.3 with you guys so that you can get started on your homework this week. I miss you guys and seeing you every day. If you have any questions or concerns, please send me an email and we can keep in touch. All right, let's see here. All right, hopefully this works. All right, so in section 7.3, we're looking at different types of probabilities, but first we have to learn some different types of set notation. So if you remember back from when we were meeting in class, we were making some Venn diagrams where we had two different conditions, and this could be maybe different classes that you've been taking, or just two different conditions that could happen within a population. And we could call these conditions A. People could be in set A, or they could be in set B. Okay, so maybe set A is students taking Spanish, set B are students taking French. Any students not taking either of them would be outside of these two circles. We would label this U for the universal set, and we would have these two conditions. Now, one of the terms that your book goes over is called the intersection. Set notation, we would write that as A with this upside down U and B after this. So this would be written as A intersect B. Okay, and what the intersection means is that you're looking for the points in our population where we would have events A and B both occurring. Okay, on the Venn diagram, that would be anybody in the middle there, so on the overlap. So students in this case that are taking Spanish and French, maybe they're taking both. Okay, another term that you'll need to know, set up the Venn diagram again, is called the union of A and B. And the symbol would be AUB. This is when either A or B or both are occurring. So this would be like students taking French or Spanish or both. In the Venn diagram, that would look like everything. So if I wanted to know the probability of the union of A and B, I would look for students taking either French or Spanish or both out of the whole population, and then students that aren't taking anything would be considered, that would be in our denominator. Okay. Another term is complement, the complement of A. We use a little apostrophe to denote the complement. Complement means anything not A. So the complement of A, if A was students taking French, the complement of A would be any students not taking French. In the Venn diagram, if I wanted to mark down the complement of A, it would be everybody on the outside, because they're not in population A, and also anybody in B, but not in the overlap. Okay, anybody in the overlap would be a part of A, and so we wouldn't count them. Okay, so it would be anybody not taking French. Students taking French and Spanish, they're taking French, so they wouldn't be included in the complement. Okay, and lastly is a conditional. It's not going to have a drawing, but a conditional would be something like this. And we would read it as the probability of A given that B has occurred. And we'll look at some examples of that. But I don't think that'll be today. I think that we'll look at the conditional ones on Thursday. Okay, so I wanted to go through some examples with you, examples from your book. So if you have your book, I'm on page 320. I'm going to go through example 9 with you guys, and we can do a couple of the problems together and make sure that we know what we're doing. So I'll start with, like I said, example 9. Okay, and example 9, they have students chosen at random from a class, and then there are classes, an ESS class, a geography class, and then and they're labeling that as E, G, and then it looks like there's an S as well. What's that for? Okay, so I'll just redraw the Venn diagram here. Okay, and they have U, and then there are 2 students outside of everything. There is this big bubble E. There's a subset inside of E that they label S, and they don't really define what S is. And then there's G, that's the geography. And then there's 1, 3, 2, and 3. Okay, so if I was reading this, there are 3 students taking E but not S. There's 2 students taking both S and E. There's 1 student taking both E and G, and then 3 students taking only G, 2 students not taking either E, S, or G. And again, they didn't define what S is, but that's okay. So we want to find some probabilities here, and they're using kind of complex notation to ask us what these probabilities are. So the first probability is what's the probability that a student is in the intersection of E and G, and G and E. All right, so two intersections here. Now, if you notice, they're listing both of them, but this is actually the same thing. If we were going to shade in this region of the Venn diagram, the intersection of E and G is where they overlap, and we're overlapping the same area on the Venn diagram. So whether the E is listed first or the G is listed first, it doesn't matter. It's going to be the same probability. So a student chosen at random out of this population, there's only 1 student that satisfies this intersection. So that's going to be in our numerator. And then our total population of students that were surveyed is going to be the 2 here, the 2 there, that's 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 total students. So for A, the intersection of E and G, or G and E, is going to be 1 student out of 11. Okay, and they are they're the same, the probabilities. Okay. All right. For B, we want to know the union of E and G and G and E. Probability of the union. And again, the order here doesn't matter, so this is actually all the same thing. Okay, the union is going to be anything that satisfies E, anything that satisfies G. So if I were going to shade this one in, it would end up being everything in my Venn diagram. Okay, even the stuff in S. S is a subset of E, so these 2 students, they're taking S and E, so they would count as students taking the E class. All right, so if I'm tallying it up, my total students are still out of 11, but now I'm surveying 2, 3, 4, 5, 6, 7, 8, 9 out of 11 would be the probability, okay, that they're taking the ESS class, geography, or both, okay? Next, I'll have to go to another sheet of paper. We want the complement of E, the probability of E's complement. So that'd be any students not taking the ESS class. All right, so if I go back and I look at my drawing, how many students aren't taking the ESS class at all? It's going to be these 3 students and then these 2 students. So that's 5 total students out of the 11. So this will be 5 students not taking the ESS class out of 11. All right, and then lastly, the probability of E given G and the probability of G given E. Now these are going to be different. We'll have to tackle each one separately. All right, so we'll look at E given G. So what this means is that we know the student is taking geography. This is given to us. So it lowers our set of total people in the problem. We know that the student is taking the geography class. So if I go back and I look, I'm going to recreate the Venn diagram right now real quick, just so we can see it. Okay. I know that they're taking G. All right. So my whole world, I get rid of that part. The only students that I'm considering are these students. So my total number of students is out of 4, because there's only 4 students that are taking the G class. All right. Now, how many of them are taking E? That's going to be in the overlap here. So it's going to be 1 out of 4 for the probability of E given G. Now, if I look at the other probability, the probability of G given E, that's going to be a little different. I know that they're taking the E class, so I get rid of these 2 populations, and the total number of students is going to be this 1, that 3, and that 2. So now there's 6 total students, and the probability of them taking the geography class, there's only 1 student out of those that's taking the geography class. So that's going to be 1 out of 6. All right, so if you notice, these 2 aren't the same probabilities. When you have a conditional like this, the order of the letters matters very much, and it's going to restrict what your final numbers are going to be. All right. Let's see. Next, I wanted to look at example 10. Okay, so we turn over to page 322. You can look at example 10. It says, Katerina explores the names of the students in her class of 15 students. She sorts through the data for all 15 students and determines sets A and B. Sets A are students with exactly 2 vowels in their name, and set B are students with exactly 3 vowels in their name. Okay, and there's a list of students A and B. Now these students would not be overlapping. So if you look at the Venn diagram that's set up, it's A and B, and there's no overlap because the student can't have only 2 vowels and only 3 vowels in their name. There is no overlap. Okay, and there's 15 total students. I'm not going to write their names out, but there are 5 students in set A, and there are 6 students in set B, and there's 15 total students. That means there's 4 students outside of there that don't have 2 or 3 vowels. They must have either maybe 1 vowel or 4, 5, 6, 7 vowels. All right, and we want to find the probabilities of A, B, and then the intersection of A and B. So the probability of A, there are 15 total students. The probability of A would be 5 out of 15. There's 5 students in set A. The probability of B, still 15 total students. It would be 6 out of 15. The probability of the intersection of A and B, there is no intersection. Okay, so there's still 15 students, but none of them intersect. So it's just going to be 0. And you can write it as 0 out of 15 or just 0, and that would be okay. Because there is no overlap. Okay, and the term that we use here is mutually exclusive. So we would say A and B are mutually exclusive. And what that means is that if A happens, if you're in A, then B can't happen. And vice versa.
Daddy?
Not right now. So if you're in set A, you can't be in set B. If you're in set B, you can't be in set A. Okay, so you can have 2 vowels in your name exactly, or 3 exactly, but you can't have both. Okay, and then the other term that you're going to be expected to know is what a complementary, with complementary events, if we would say A and A prime are complementary, and what that means is that together their probabilities add up to 100%. A plus A prime, the probability of A plus the probability of A prime is 100%. In the example of this problem, the probability of having 2 vowels in your name plus the probability of not having 2 vowels in your name adds up to 100% of the population. And sometimes you'll calculate answers based on knowing that something is the complement, and you can subtract from 100%. It makes it easier. Okay. So these 2 are mutually exclusive. That was part B. And then lastly, part C. I think I'm still on screen here. There we go. Part C here, we want the probability of the union of A and B. Okay, which would be the probability of a student having either 2 or 3 vowels in their name. So there's still 15 total students. The probability of them being either 2 or 3 would be 11 total. So that would be 11 out of 15. Okay. Okay, and I think that should be enough for you guys to dig in. You can look through example 11. If we have questions, I can address it during the office hours that are going to be on Wednesday. And if you have any questions, just email me. I would like you guys to do all the problems in exercises 7F on page 324. And like I said, if you have questions on Wednesday, we can talk through any of the problems. Hope you guys are doing well, and I hope this was helpful. I'll talk to you later.